Okay, today's presentation we will cover basic switch configuration and end device configuration. So this will be some stuff that we've seen already in Tuesday's class, with some new stuff on the actual using command line interface to actually set up the basic switch configuration on equipment, so actually get in and do something. Now we will be using Packet Tracer for this activity, as we aren't in a classroom with equipment, so we'll stick with Packet Tracer for now. And it's not going to be that far off live equipment, so you don't get to plug cables in physically. That's about it. Okay, so the first thing we need to discuss is how operating systems work. This is regardless of the platform. You have three main parts of any operating system. You've got the hardware that it runs on, the kernel, that is the interface between the hardware and the software, the shell, and the shell is our user interface. Okay, so the shell is your Windows or your Linux interface that you use. Now, when we deal with a Cisco operating system, the shell is command line interface, whereas a Windows 10 or 7, that would be a graphic user interface. So it's just about how you display that user interface to get input and communicate with your user on the platform. So, all right, so basically that's going through everything that I've just said. Plus, operating systems can crash. They're like anything else. Software can glitch and just hang up. Now, we use these operating systems to generate the platform and the interaction point between the applications we want to use and the devices that make those applications run. So the input can be via a mouse and clicking, or it can be text-based, or a combination thereof, and you have some form of output and feedback to the user on how that's performing. So how do you access a Cisco device? Well, you've got three main options, which basically is really only two, just we say three because one's secure and one's not secure. So you got a console port, which is a physical configuration cable access, and we call it a console port, and it would be a sky blue cable, flat ribbon cable, traditionally with a D9 plug on one end and an RJ45 on the other, and that would plug into your comms port, your serial port. In today's environment, this is slowly changing over to a USB cable and being plugged straight in as a USB on the newer devices. that's the only way to put in an initial configuration as, you know, out of the box. Telnet and Secure Shell are methods for remote configuration, but they need basic elements configured on the device before you can use these remote shells. So SSH Secure Shell encrypts all your messages, so nothing can be intercepted and derived from, whereas Telnet is in plain text, and people can use a very easy software package called Wireshark to actually watch what you are typing every single command. So these programs use a terminal emulation program such as PuTTY, Hyperterminal, Teraterm, Secure CRT. There's a bucket load out there that do this. And basically you have to tell it what type of connection it's going to be. If you're using SSH or Telnet, you basically got to give the IP address of the device you want to connect to. If you're using the console port, you got to click serial. Okay. So within the device, we have a user prompt that tells us information about where we are within the operating system. And the very first starting point is whether we're in user or privileged mode. So user mode is for basic monitoring of the device, and privileged mode gives us full configuration access to the device. So in user mode, you've got a very much cut down number of commands that you can access, and when you go into privileged mode, you get all the commands and the various modes that come up underneath it, like the global configuration mode, where we change the prompt so you start getting specific modes displayed in between the brackets. So if it's config, it's in global config mode. Config-line is your line configuration mode, which we use to configure our remote access to the device via Telnet, for example. Then when we want to actually configure the ports that devices plug into the switch or the router, we need to go into our interface configuration. So we've got IF to say that. So that's where we would configure our gigabit interfaces or fast Ethernet interfaces with specific configuration points. Like on a router, you put in an IP address, subnet mask, that sort of thing. Okay, so to change from user mode into privilege mode, or sometimes referred to as enable mode, is we enter the command enable, thus the enable mode jargon. So you'll see that the prompt at the end changes to signify which mode you're in, and to step back a level, we type in exit, which will take us back one level of configuration, if you like. So if we were on just the hash prompt and we typed exit, it would take us back to user. So it's a very much hierarchical system of commands, and to step through them and reverse is to enable or exit. The other one that we'll probably see in a couple of slides is end. When you're in any of the config modes, if you type in end, it'll take you back to the privileged prompt. Excuse me. So after changing modes in the privileged mode, to go into global config, we type in configure terminal, and that gives us that one. And the line commands are accessed via line and then the port number. So the type of port, console port, and the sequence number of the ports. They all start at 0. On a switch, you can have, hundreds of ports, so you've got to know each interface identifier. And we tend to separate layer 2 connection points and layer 3 connection points by saying layer 2 is a port, layer 3 is an interface, just to give you a understanding of which mode of discussion we're talking about. When we go into subconfiguration modes, this is where you get the hyphenated structure within the brackets. So this tells us that we're in config and line submodes. The way to step back, as I said, one level is the exit command. All the way back to this prompt is the end command, or shortcut key is Control Z, which is equivalent to typing in end. So how does the structure of the commands work? Well, you start off with the device prompt. Then you have your command, then a space followed by any keyword / augments afterwards. So basically the commands show what part of the show command do I want to access. I want to access the IP subset, specifically the protocols that run on IP. In this one, we want to ping, and we want to ping this device. So we want to check whether we've got connectivity to a specific device. So structure within documentation here. So we've got the boldface, the italics, and all the brackets. I'm not going to read them out. You know how to read. So basically the bold is your command, and then your augments are italics. Fairly simple and straightforward type of, So we've got an example down the bottom. So all the switches that are active within the command. Now, the great thing about the Cisco's operating systems is that it has an inbuilt help feature, which is accessible via the question mark. So if you're unsure what comes next, you just type in question mark, and I'll give you all the options that are available from this point onwards. So this is known as context sensitive help, which basically gives you the possible inputs from any given point within a command. If the device doesn't understand what you've typed, it'll come up with this little caret symbol at the point that it no longer understands what you are entering. So in the privilege mode, interface is a valid command, but not in this format. So it's saying, I don't understand what you're typing from this point. So it tells you where a potential typo has occurred. For example, hotkeys and shortcuts are used throughout operating systems in this environment, and what you need to type in for a shortcut to work is enough letters for it to become a unique command. So in the example here, we have con, which is ambiguous because it can be configure or connect. So con is not enough for it to tell what command you are trying to type. Basic rule of thumb, if, I haven't covered this, but if you are partially through typing a command and you hit the tab key, if enough of the command has been entered, it will fill in the full command thereof. Basically, where you can hit the tab key and get the autofill to occur is where you can shortcut from that point, because it's a unique command. So global configuration is accessed using configure terminal. Shorthand is conf t. A lot easier to type, a lot faster. So there we go. Shortcuts. Tab completes a partial command. Backspace erases your left and right arrows to move your cursor back and forth, and up arrows and down arrows to record your history of commands already accepted into the interface. Again, enter to display the next line in a prompt. After the more, spacebar shows the next page, if you like, and any other key after that more prompt is displayed will terminate the display being shown. Cancel configuration commands and so forth within the operating system is generally Control-C. Where that doesn't work, such as doing trace routes, you use Control-Shift-6, and that's your all-purpose break sequence to break any input or output automation that is occurring. Now, out of the box, your default name of a device is switch, router. So you need to change the device name as soon as possible. Use something that represents its location or function within your network. So in the example here, they go in and change it to switch first floor. Okay, so floor 1 is first floor. So guidelines, a name always has to be an alpha character first. It is not allowed to contain any spaces in the name. So if you have a space between switch and floor, it'll consider SW being the new host name. So no special characters, letters, digits, and dashes are allowed, and a maximum of 64 characters in length for the host name. Passwords should be configured on every device as you go through. This is to stop people accessing your device unauthorized. It's the reason we give users a user account and get them to set a password. So it uniquely identifies the user and provides a basic level of authentication to prove that that user is accessing the device in an authorized manner. So guidelines: passwords more than 8 characters in length, combination of upper and lowercase, special characters and numbers and sequences should be used. You shouldn't use the same set of passwords across multiple devices, and avoid using common words as passwords. Throughout the curriculum we will go through, we shall generally use Cisco or class as default passwords in the lab environment. This is so that it is easy password recovery for me. When we start getting students being creative with passwords, I have to go through a few hoops to reset default settings on devices, and switches in particular can be a little annoying because you've got to actually unplug the power, which is on the back of the rack, and then hold the button on the front of the device when you plug the power back in to start the sequence. And the sequence for password recovery differs depending on the model of the device you are using. So don't test my memory too often. I may embarrass myself. Don't worry, Uncle Google shows you how to do it anyway. So the password recovery is in the user documentation for each device and can be accessed via cisco.com. So after we set passwords on moving into enabled mode, we need to set passwords on our remote access. So this is how we do it. So the first one is enable secret and then the password. So what we're saying is when we move into privilege mode from user, the enable command, we need to enter the password class. What the secret parameter there does is it tells the device to use a hashing algorithm to encrypt our password so that it is not displayed in plain text when we do a show command. On our lines and our virtual terminal sessions, we need to put a password in, and in this case we're using Cisco. So every time you go to access the device via the console port, it will prompt you on login for this password. So that's the command structure. Line console 0, password, Cisco, login, and so we're telling the device that whenever a person connects via the console port, prompt the user for a password before proceeding. As I said before, whenever we change modes from user to privileged, prompt the user for a password. The other command that you'll see in documentation is enable password class, for example. If you use enable password, that's plain text. It can be seen. So we tend to only use the enable secret password. The virtual remote sessions, VTY lines, are virtual terminal sessions. Now, switches have the ability to have 16 concurrent sessions running at the same time. So, thus, lines 0 to 15 have to be configured. You can configure individual lines, but the line number you get is dependent on how many connections the device has at any given time. So it randomly will assign a line. So we tend to configure them all as one group, so they're uniformly configured. And again, exactly the same password and login sequence as we used on the line console port. Now, to give a small level of protection of our passwords that we enter into our configuration, we can do a very low level encryption, which is service password encryption. This provides a level 7 encryption, which is a very easy to break level of encryption. So easy, in fact, that Cisco themselves has the de-encryption tool on their website. Okay, that's how easy it is to unencrypt a level 7 encryption. You just go into cisco.com and look for the password decryption section, and it'll unencrypt a level 7 password. These are there just to stop people from looking over your shoulder and reading what your passwords are. That's the only reason we use password encryption. If we don't enable service password encryption, our passwords would be in plain text right there when we do the show commands on the configurations. So they would be displayed for everybody to read. The main banner that we'll look at, which is a message that comes up, for example, when we change modes or do certain things within it. The main one we'll be looking at is message of the day. Now, this is displayed when the person first connects to the device. And the command structure is banner, MOTD, and then the message incorporated in a unique character. So the hash symbol here and here represent the start of the banner message and the end of the banner message. That character can be any character you want. as long as it's not within the message itself. Alright, so if I had a hash value in here, it would close off the banner command and the rest of it would be unrecognizable text. So it's general rule of thumb that you put some form of warning on a device saying authorized users only or something to that effect. Otherwise, and you don't use the word welcome in your banner. Welcome is interpreted in legal circles as an invitation. Okay, so when you welcome somebody to your device, you're inviting them to access your device. That was set in legal precedence in a hacker's court case many, many years ago. Saving configuration files. First off, we'll say there are basic elements. Okay, so on a Cisco device, you have two configuration files, if you like. You have a startup configuration, which is saved in NVRAM, and this is what is used when the device powers on. Your running config is in your RAM and is only valid while the device is powered. Any changes to your configuration is done to the running config file. So it was not automatically saved back to the startup config. So anything you type in the config, global config command, that sort of thing, affects the running configuration. It does not affect the startup configuration unless you save it out. To look at the contents of either of these devices, you type in show startup config or running config, and you can see when you look at those things that they can be different. Right? As I said, one is a live version of the other. You need to save. I don't think we actually talked about the actual saving. Go back. No, we didn't. Okay, there it is. We need to use, Mark, don't use your mouse button. Baldy, fingers off the keyboard, off the mouse. Okay. The command to save your running config to your startup config is copy run start. All right. It is displayed here as the full ugly command, copy running -config space startup -config. But on 90% of devices, all what you need to type in is copy space run space start. Okay, 90% of the devices will do that. Please try to avoid using the write command. If you're using some of the older documentation, you will see WR being used. Some of the YouTube clips and that will have it out there. WR is a legacy command, and they are dropping it out of newer versions of the operating system. just to give you a heads up. Reload is a soft reboot of the device. So it's equivalent to the restart command in Windows, for example. And one of the things that it will prompt you for, if you've got a difference between the startup config and the running config on the device, is it will ask you whether you want to save your current files or not. So it will prompt you here on the reload, do you want to proceed? And it'll also give you some other prompts regarding saving your files and stuff too. The erase startup config will erase that save file out permanently. And again, it prompts you whether you want to continue or not. So it gives you the out, as in, did you really mean to tell me to delete our startup files? Yes, I did mean it. Capturing text. Now, on here, I'll just say you need to know this method. All right. You need to send it to a log file and output it. You need to know how that is done. But it is not how we do it. Guess what? Once you're in a terminal session, if you just highlight your text and do a whole copy paste routine to a text file, you've just done your backup. All right. But you need to know how to capture text for answering the questions in exams, both within the chapter exams and the certification exams. IP addresses, I won't go through it again. We did it on Tuesday. I think we've done it 3 times now. Entering an IP mask, subnet mask, default gateway, how it works, IPv6, same thing. Again, we've been through it, so I'm not going to repeat it. Again, going through cable types, copper, fiber, wireless, media, and the various ports, and how they connect and terminate. I think you just read that on Tuesday, yeah? For IT Essentials, so I won't spend any time there. Alright, just like we did on Tuesday, DHCP settings, use the following IP address is a static configuration, and obtain IP address automatically is where it uses DHCP. And I'll just bypass those slides. You don't need me to repeat them again, especially concerning it was this week that I said it in the other subject. The configure terminal and interface VLAN 1 is a unique thing to switches. So what we're doing here is setting up a virtual local area network interface on the device. Now, every switch will have a VLAN 1 in Cisco. It's a default VLAN that is on every device out of the box. And what we do with it is we configure an IP address and subnet mask and tell it to be no shutdown. which is the opposite of shutdown. And I'll explain that in a second. So you need to configure a IP address on the device so the device can be remotely managed via Telnet or SSH. Switches are a layer 2 device, so all the ports, they're called switch ports, so therefore they're layer 2 connections don't have an IP address. They only use the MAC address. Yeah, Christopher, yes, I did say they overlapped. But yeah, now I understand why I wanted to get those 2 chapters out of the way with IT Essentials before we moved on to virtual machines, because it just made sense right now that they kind of work together. The purpose behind configuring a VLAN with an IP address is so that you can always get to that device remotely to configure it remotely. Otherwise, you have to walk up to the device and plug in a console port every time, which is painful and not necessarily practical. All right. So the no command. Let me explain the no command a little bit. In Cisco operating systems, you reverse a command by putting no in front of it. So the default command that is in place on interfaces, for example, is shut down. So we want to enable this interface, turn it on, so we type in no shutdown. If we wanted to remove an IP address, we would put no IP address and type in the IP address to remove it. Now, a word of advice with the IP address command. It is the last address that is typed in that is active. So if you type in IP address 120, IP address 121, then the 121 would be the active IP address on this VLAN. So that's unique to as well. We used to use secondary IP addresses within interfaces in the lab environment, which was fun. Verifying connectivity is the ping command, and why there's no slides here is because I've deleted them, because they basically said go do a video. Alright, so watch this video. So I deleted the slide, but as per their discussion in the week, the ping command is how we verify connectivity, and basically you'll find a activity to do in Packet Tracer with that as well. So what did we cover? We looked at the basic structure of every operating system, as in shell, kernel, hardware. We looked at the 2 main modes within Cisco devices, being user and privileged. We looked at the various ways of working out which mode you're in. So we looked at the command prompts. Command prompts tells you whether you're in user, privileged, global, or a sub-configuration mode, all in that nasty prompt. We looked at how to do the host name, how to set passwords, how to encrypt the passwords, and set your banner. Now, in this chapter, we've talked about how to do it on switches. When we move to a router, the only thing that changes in amongst all of that is instead of putting an IP address on a virtual interface, we actually put it on a physical interface that is connected to our network. All right, so how to save a configuration and the difference between startup and running config files, and how to archive that off the device itself, either using the capture command sequence in PuTTY or just doing a straight copy and paste. Now that's basically all the lovely, but I thought I'd just do a bit of a, alright, so, look, there we are. See all those link down statements? So it's in shutdown mode and we need to turn it on. That's why we use the no shutdown, because when it's down, it's not usable. So how do we get in there? Well, in Packet Tracer, the little bit of unrealistic thing we can do, it's just click on it and then enter the command line. All right. So we can't do that to a live device. We can't. It's just not possible. All right. So to simulate what we do in the live environment is you grab a laptop or a desktop, doesn't matter which, and then in your cable settings, you use the sky blue cable, which is your console cable, and you connect it via the RS232 port, and then bring it across and plug it into the console port. All right. So this is how we physically do it in the real world. You then go into your laptop, into your desktop settings, and you run your terminal. So this is setting up the parameters of your terminal session. Now, whether you want to use that or not, it's up to you. But it's there. So there's your Telnet SSH client. There's a text editor, so you can paste or capture into that. So when you set up your terminal session and you use the serial line, which we did there, we connected via the console port, the RS232, to the console of the device, we need to tell the operating system how to configure that comms port. How many bits per second we're going to use, how many of them are data bits, whether there's parity and stop bits and so forth. So that's the default settings. Just hit OK. And that takes you into the command line of the device. So this is the screen of it, parameters, and doing its self-test, loading its operating system, doing a check on all of its cards and plugins and stuff like that. Then it comes back and says, I'm a switch. Alright, I've got 26 ports. This is my model, and this is the version of operating system, and that's the name of the operating system image that I'm using. So basically that's equivalent to saying it's Windows 7, but it's release 12.2. Okay. Hit enter to activate the user prompt and type in enable, again shortcuts, EN. The prompt changes to the hash. This indicates change. Then enter global configuration, conf-t, and the first thing you should do is change the host name, because every switch in your network, when it comes out of the box, is going to be called switch. So if I put the question mark there, it says a word, this system's network name is expected as the next input. So switch ground floor, ground floor. So you give it a name that indicates where it's located or its function. What else do we need to put on there? Passwords. So it's enable, and again I'll use the question mark to show you here. So if you use the password now, this is plain text. If we use secret, it encrypts it. So I'll just do the password at the moment, and we'll go Cisco 1, and I'll exit out from there and go a show running config, so show run, and we go through. It says what the version is, timestamps, whether it's got password encryption. Here's my host name configured, and here it is for all to see what my password is. So not a good thing. Notice them all prompts. Hit enter, one line at a command at a time. Hit the space bar, it fills the screen. Okay. So I just wanted to give that visual representation. And all right, so you've done the show run. How would you save that off to a text file? As I said, you can use the capture command, but what most of us do is just grab from that tag underneath the version and pull down to the end and do our lovely copy and paste function. Now, depending on what version of terminal you're using, that could be automatic. As soon as you highlight something, it puts it into the clipboard. You might have to hit enter, depending on how it's used. And then you just move into a text editor and paste it in, and that gives you a copy of the config. Now, one of the things you can do is actually, if you remember all your command structures properly, like I can configure it from the text file. Go IP address 192.168.156 with a subnet mask of 255.255.0, and I want it to open so it's a no shutdown. There's my line console. I want to set the password to class, and I want you to be prompted for that on login. Same with the BTYs. And all right, so I can just now, let's go no enable password that, and then put in enable secret, and we'll keep it as Cisco one. And so that's very much a different configuration than what I had. Go back. Yes, I want to save that as test. Close it off. Go back into the main terminal session. It will still be sitting where it was. Now, I need to enter configuration mode, and then I can just paste, and you'll see it'll enter. So it didn't like the no enable password and the password being specified. So there's your prompt. Spanning tree extended, didn't like that. There's my passwords. So if I do a show run, there's my enable secret. See how it is encrypted. And if I scroll down, there's my console ports. There's my IP address. So now, if I was to step back out into exit and try to come back in, I now get prompted for a password. And if you don't get it right, you're locked out. So once you, alright, so have fun. There's various ways of doing it. Now, I didn't save that configuration at all. So if I was to go into the switch and unplug it, so to speak, I would lose all that configuration. Same as if I came in here and did a reload, but I can't do that from this mode. It's an unrecognized command. So you've got to have physical access to do a password recovery. That's what I'm getting at. So have a play. I believe there's 2 or 3 packet tracer activities for this chapter, all around setting up and getting in, doing these devices. Now, if you forget your password on a device in here, in Packet Tracer, we can just come in the config and erase our startups. Okay, and everything is forgiven, basically, because there's the user prompt. Now we go in the command, there's the user. So we can totally bypass steps in the packet tracer that you cannot do in live equipment. So as I said, it's almost the same as live equipment, but it isn't the same. It is a simulator. So have fun doing that. You'll go in and do activities that get you to actually do all these commands within Packet Tracer. Is there anybody that hasn't downloaded and installed Packet Tracer online at the moment? No? All right. In that case, I shall let you